Beneath Antarctica's endless ice lies a world of profound mystery, a vast, ancient ocean, untouched by sunlight for millions of years. Locked away under kilometers of solid ice, this dark, silent realm is not a frozen tomb. It's moving, warming, and changing in ways we're only beginning to understand. Immense forces, geothermal heat, crushing pressure, and subtle ocean currents are awakening this sleeping giant. Tonight we journey into this abyss to uncover the unsettling truths that lie in wait. We'll explore the science racing to keep up with rapid changes in this remote place, and we'll reveal why Antarctica's hidden ocean terrifies the scientists who know it best. Antarctica is a continent larger than Europe, buried beneath an ice sheet nearly 5 kilometers thick, but below this frozen shield lies a vast, interconnected system of rivers and lakes, an ocean trapped under ice. In this absolute darkness, water remains liquid under crushing pressure, isolated from the atmosphere for millions of years. This pristine environment is a scientific treasure trove, preserving clues to Earth's past climate and possibly the origins of life. Yet, its isolation makes it vulnerable. Any change could ripple through this ancient system unpredictably. Hundreds, perhaps thousands of subglacial lakes are connected by hidden rivers, with Lake Vostok as the largest. The discovery of this dynamic hydrological system has transformed our understanding of Antarctica. As we peel back the ice, we realize this hidden ocean holds immense power and potential instability for the planet. The existence of liquid water in Antarctica's deep freeze is a scientific paradox. Temperatures here plunge far below freezing, yet water persists thanks to 3 powerful forces. First, the immense pressure of kilometers of ice lowers water's freezing point, keeping it liquid at sub-zero temperatures. Second, geothermal heat from Earth's core, trapped by the insulating ice, melts the base and replenishes the subglacial system. Third, in some regions, ancient sea salts further lower the freezing point, creating supercooled brines. This delicate balance of pressure, heat, and salt allows a hidden hydrology to exist in the most hostile conditions. But it's a fragile equilibrium. Small changes in heat, pressure, or salinity could disrupt the entire system. The water that shouldn't exist is there because of a precarious balance, one that's now being disturbed. Scientists once saw Antarctica's ice sheet as static, but the discovery of vast, hidden rivers changed everything. Using radar and satellites, we've mapped a continent-spanning network of powerful rivers flowing in darkness, miles beneath the surface. These rivers transport huge volumes of water, lubricating the base of the ice sheet and influencing glacier movement. Subglacial lakes can fill and drain suddenly, releasing torrents that destabilize the ice above and accelerate glaciers toward the sea. Each flood acts as a destabilizing jolt, making the ice sheet more vulnerable. Satellite data now lets us watch the continent breathe as the ice rises and falls with hidden water movement. As the climate warms, more meltwater could trigger larger, more frequent drainage events. These hidden rivers are now seen as a critical and terrifying variable in Antarctica's future. While subglacial rivers shape Antarctica from within, a more insidious threat attacks from the edges. Ice shelves, vast floating platforms, are being melted from below by warm ocean currents. These currents, just a few degrees above freezing, are funneled beneath the shelves, relentlessly eroding them from the bottom up. Robotic submarines reveal vast inverted landscapes carved by this hidden melting. The process is far more efficient than surface melt, concentrating damage in vulnerable areas and accelerating decay. From above, the ice may look stable, but beneath, it's being hollowed out by the ocean. The fate of Antarctica's ice may be decided in these dark, warming waters. Ice shelves aren't just extensions of the continent, they're Antarctica's braking system. They hold back colossal glaciers, slowing their flow into the sea. When ice shelves are weakened by melting or fracturing, this braking effect fails. The collapse of a shelf unleashes the glaciers behind it, allowing land-based ice to surge into the ocean. This is the true danger. Land ice entering the sea raises global sea levels. The health of these breaks is a direct indicator of our future. Across Antarctica, these breaks are failing, opening the gates for vast reservoirs of ice to pour into the ocean. The consequences for sea level rise are profound. In West Antarctica, the Thwaites Glacier, ominously nicknamed the Doomsday Glacier, has scientists alarmed. Thwaites is the size of Great Britain and is already responsible for 4% of global sea level rise. Its instability comes from resting on bedrock that slopes downward inland, creating a feedback loop as it retreats. Warm ocean water is melting it from below, and its grounding line is retreating rapidly. If Thwaites collapses, it could trigger a chain reaction, destabilizing neighboring glaciers, and potentially the entire West Antarctic ice sheet. This could raise sea levels by over 3 meters, redrawing coastlines worldwide. Thwaites is the linchpin, the weak point in Antarctica's armor. Its fate may be the most important question in climate science today. In the crushing darkness beneath Antarctica, life has found a way. Subglacial lakes, once thought sterile, are home to extremophile microbes, organisms thriving without sunlight, surviving on chemical reactions with bedrock minerals. Recent discoveries even include mysterious, sponge-like animals clinging to rocks, far from any known food source. These findings challenge our understanding of life's limits and hint at a hidden, unexplored food web. But our exploration risks contaminating this ancient biosphere with surface microbes. There's also the unsettling possibility of unknown organisms for which surface life has no defense. Antarctica's subglacial ocean is a hidden biological realm. Its secrets and dangers remain largely unknown. We are only beginning to glimpse what lies beneath. The water beneath Antarctica's ice is a liquid archive of Earth's deep past. It holds clues to ancient climates, trapped air bubbles, and even dormant bacteria and viruses from millions of years ago. As the ice melts, these ancient organisms are released into the water for the first time in ages. While the risk of a pandemic is low, the sheer scale of melting means countless ancient microbes are being set free. The release of ancient carbon-rich material could also fuel greenhouse gas emissions, creating a feedback loop of warming. We're tampering with a system sealed for millions of years, and the consequences are unknown. Some secrets, perhaps, are best left buried. Unlike the Arctic, where melting is visible, Antarctica's greatest threat comes from below. Warm ocean currents melt the ice shelves from underneath, out of sight and hard to detect. This melting is highly targeted, focusing on the most vulnerable glaciers and undermining the ice sheet's foundations. The changes are subtle until a critical threshold is crossed, then collapse can be sudden and catastrophic. Antarctica holds 90% of the world's ice. Its stability is crucial for sea level rise. Yet it's being dissolved from its base by forces we can't see. The real drama is unfolding in the dark, hidden from view. Antarctica is alive with sound, a symphony of groans, cracks, and booms as the ice shifts and fractures. Sensitive seismometers reveal constant ice quakes, signals of stress and decay within the ice sheet. As glaciers accelerate and ice shelves thin, these sounds grow more frequent and intense. Hydrofracturing, when meltwater drives cracks through the ice, can shatter shelves in hours, signaled by a cascade of cracks and pops. The loudest, most stressed areas are often those melting fastest. These sounds are the continent's warning. Its braking system is failing, its structure coming apart. The ice is speaking, and its voice is one of pain and imminent collapse. The fate of Antarctica's ice will shape the future of our planet and civilization. If the West Antarctic ice sheet collapses, over 3 meters of sea level rise would follow, flooding cities and redrawing coastlines. The influx of cold, fresh water would disrupt global ocean currents, altering climate and weather patterns worldwide. The Atlantic meridional overturning circulation could slow or collapse, plunging Europe into colder conditions. Extreme weather, droughts, and storms would become more common. The collapse would trigger a cascade of climate tipping points, forcing mass migration and global instability. The stability of Antarctica's ice is linked to the stability of our societies. If Antarctica goes, our world changes forever. Scientists studying Antarctica speak with a rare sense of fear. Born from understanding the system's tipping points, the ice sheet won't melt gradually, it has critical thresholds, like the marine ice sheet instability at Thwaites. Once past these points, collapse may become unstoppable, regardless of future emissions. The timescales are planetary, centuries or millennia, but the process, once started, is irreversible. We can't refreeze a continent or push glaciers back uphill. The decisions we make now could lock in meters of sea level rise for generations. Unlike other environmental problems, we can't undo a collapsed ice sheet. This is why scientists are truly afraid. We may be witnessing a global tipping point in real time. Antarctica's hidden ocean isn't sleeping, it's moving, changing, and growing warmer each year. The equilibrium that held for millions of years is unraveling, with consequences for every coastline on Earth. The scariest part is what we don't know. Most of this realm remains unexplored. We're witnessing the destabilization of a planetary system based on only glimpses of data. The changes here are a silent warning, a harbinger of a different world to come. Some dangers stay hidden until they change everything.